Hello and welcome friend. In this tutorial we will look at exception handling. Exception handling are a means of any programming language in which if there is an error, then how do we gracefully handle that error. If we don't handle the exception or if the exceptions are not produced, the script would be terminated, by which any statement after the exception will not be executed and the program will exit if we don't handle exceptions. So let's see what are the exceptions, how they are being handled in this example. We have two variables x and y variable is set to 0. Now typically when we divide x by y, which is division by 0, in mathematical terms that's infinity. In computer the infinity is not defined like that. The reason being there is no limit to infinity. So how do you set a limit to infinity? Even though some programming language designates a very large number like the size of a long or a size of a integer as infinity, but if you divide by 0, that does not gives you infinity, that gives you an exception. So let's see about this. If I do x by y and save this program and run this, so if you see the console error, the program exit and it says division by 0 error. Let's write a statement below this line. If I say print hello, now run this again and you see that print hello has not been executed. The reason is when there was an exception here, the exception has been thrown on the screen at the exact line number, that line number 6 generated an exception division by 0 and it terminated. Now when it terminated, it will have a side effect that if your program is running and if there is a socket error instead of this division by 0 error, if there is a network problem and there is an exception due to network and you have a code to do some networking, it will exit, which is not a desirable outcome. So how do we handle that? So you will write try in a most generic way, and whatever things you know might generate an exception, like this statement x equals to 10 will never generate an exception because it's just an assignment. Now y equals to 0 again will not generate an exception as it's an assignment, but x divided by y, this operation, so you have to know which operation can generate an exception, and those things can be tied up to try and except block. Now I'll say except exceptions and that's all, and I'll say print there is an exception now. Okay, now when we say print there is an exception, it will say there is an exception, but we don't know what is the type of exceptions which has been generated. Even though in the previous case we saw 0 division error, but when we handled, we wanted to know specific what happened, what kind of exceptions, why there was an exception. So we can print the exception object. So we can say exception as e. This e can be f also, doesn't matter. So now we will print e as well. Let's see what it gives us. Now if we run here, it says there is an exception which is our statement and then followed by e, and then e is division by 0. So this is a simple English term, division by 0 exception, even though in the language the exception is listed as 0 division error. So let's check at our second example. In the second example, what we did is same code, but we have listed not just exception as e, but we also listed 0 division error. Now let's run our second code. So it printed me some exception occurred, which is this line, and then 0 by division, because 0 by division error as the first exception I handled. So if you know the specific exception, then you can list it down in the order, and then finally you will put this statement. This is a generic exception statement. If nothing occurs like 0 division error or anything else, then it will be caught here. Now this will definitely be caught because it's a generic exception. If you want to see what are all the different types of exceptions, you can go in the VS Code and go to the definition, and you can see some of the types like zero division error, overflow error, module not found error, index error, and so many other things, value error. You can see this. Now let's look at another example. In this example, I have added something more to that. So we have a try and except block, which is like in C language, if you see, it's like a try catch block, something similar in Java as well. Now there is something called as finally. Finally means that whether the exception occurs or not occurs, this finally block will always be executed. So now here see, we have, let's see, y value is 0. This will generate an exception. When this will generate an exception, it's a zero division error. It will be caught here, right? If we are not handling this, of course it will be caught here, but it will be caught here. Now when it's caught here, and after that it will print some exception occurred, and it will also generate, execute these two lines, and finally this line. So let's run this program and see the outcome. So some exception occurred, division by 0, which we know that the exception occurred here. So it is caught here, some exception occurred, and this E is printed as division by 0. Then this will not be executed because only one except line will be executed. And finally, now if you see finally, it says finally printed no matter what. We can use this to close file handle or other resources. And this is what is printed. And this is a statement 1, which means after exceptions, my script is not terminated because I am handling it. Now this is printed when there was an exception, so finally is printed. Let's suppose there is no exception. Division by 1 is perfectly normal in mathematical terms, in computer science terms as well. Now you see some exception occurred has not been printed here, neither the generic exception statement, because there were no exception. However, finally was executed. So where exactly we will use finally? Let's suppose we have some kind of a file handle, fh equals to open, and a file is, I'll give some random file which does not exist, text1.txt. Now this text1.txt does not exist. Let's see what will happen. There will be no exceptions here because it's division by 1. There will be exception in line 9. So let's execute this and see. So it says generic exception statement, no such file or directory. So there was an exception happening because of this line number 9, and the exception was not caught here because it's not a division by 0 error. So it was caught in this. Now if we handle these exceptions more precisely, like zero division error, file not found error, similar to that there is a file not found error. So if we go here somewhere, we can see in the definition file not found error. So we can use this exception. So let's copy that and let's see here. So if I say except as E, and then we'll print this line. And we'll see, let's see what is this printed. Now if I run this, it says, let's see what is this printed, and it says no such file or directory. So the exception was caught here, no more in this, because this is the exact type of exception. File not found is the exact type of exception which was generated here. So if the exact type matches, it will catch there. If nothing else, then we can have it here. And whether the exception occurs or not occurs, finally will still be printed here. You will see finally statement is executed no matter what. We can use this to close file handle. Now let's suppose this is an exception and file was not opened. But let's suppose if there is no exceptions, test.txt, and if we have a file called as test.txt, now you see there is no exceptions occurred. Now when there is no exceptions occurred, let's close the file here. So we say fh.read, we read the data, and we say fh.close. However, when the file does not exist because of any reasons, because of user inputs, or the file has been moved, this close statement and read statement will not be executed, particularly the close. We are concerned about the close because close opens a system file handle for reading the data, and that needs to be closed because there are limited resources of file handle. So this finally can be used to close the file handle. So we can use this rather than closing it here. So this is the use of finally. Let's look at another example. So this is the same what we have gone through. Now this is the else part. Now this else is slightly different. We have a try, except, and else. So finally we are clear that whether exception occurs or not occurs, this will be always executed. So let's clear that point. Now there is else. Else part will only execute if there is no exception. So if the exception occurs, this part would be executed. If the exception does not occur, this part would be executed. And whether the exception occurs or not occurs, finally will be executed. So that's how it is. Now let's see here. We have 10 and 1. This will not generate exceptions, so there will be no exception. There will be no exception, then this will be executed. So let's run this program. 5, example 5. You see, this is the else part of the exception. This is the else part of the exception. It has not caught exceptions here because there is no exceptions actually. What if there is an actual exception? So let's check, make the value as 0. And now there will be an exception, and if I run this, so there is a generic exception statement here, and finally it's printed, but not the else part. If you see here, the else part is not printed. This is the else part of the exception. So else will only execute if there is no exception. Let's look at another example, example 6. So in example 6, we have listed some of the exceptions like raise exception. Here we are actually creating an exception even though there is no exception. So if you run this program x by y, there is no exception, this will not be caught. You will only see statement 1. Let's run this program. See, this is statement 1, everything is normal. Now let's suppose despite having everything normal, and I wanted to raise an exception. I want to generate user generated exceptions, because if there is a function which is a callback or underlying functions which is not available, and I wanted to raise an exception, so I can raise in this way. So now once I raise the exception, let's see what happens. So once I raise exceptions, which means like this line number 7 will generate an exception. Then of course it will be caught in line number 11, generic exceptions, and this is a generic exceptions type. Because I'm just saying this is a shitty exception, so I'm not saying any type error exception or something like that. Let's see if we give a type error. So whatever type error I give as a string literals, that will be printed as part of a exception object. So now let's run this once again. You see, only strings are allowed. So at this line 8, this time exception is raised. This exception is called as type error. It has this value, only strings are allowed. So when the exception is raised, it will be caught in the exception block, and when it's caught in the exception block or except block, this will print my statement E, which is only strings are allowed, and this is coming from here. So this is a way either we can catch the exceptions, and when we are catching the exceptions, we can execute finally, and we can also raise our user defined exceptions. This way you can write any strings, it does not matter. So but you might want to choose the correct value so that it is reflective of what your program is doing. If there is a socket program error, network error, and you mention type error, it may not look sounds good. So you will have to look at the definitions. There is a long list of exceptions handling here, so you might have to look at the exact error and try to substitute one of them. Thank you all for watching this video, and I hope to see you in my next video.